Hi and welcome to our channel. We are in lecture 2 of quadratic equations. In previous lecture, we discussed about what is quadratic equation and what is the difference between equation and identity, and also we solved some problems based on those two concepts. And in this lecture, we are going to discuss how to form a quadratic equation and also nature of roots, and at the end again we'll discuss some problems based on these two concepts. Okay, without wasting our time, we'll start how to form a quadratic equation. So here, for that I am going to consider alpha comma beta are roots of a quadratic equation. If these two are the roots of a quadratic equation, then how to form a quadratic equation? Simply, you need to write x minus alpha into x minus beta, which is equals to 0. Otherwise, if I simplify this one, what will happen? X into x is x square, x into alpha, which is x into beta, which is beta x, and minus alpha into x, which is minus alpha x, and alpha into beta, which is minus into minus, we will get plus alpha beta, which is equals to 0, right? Here, if you observe, if I take minus x common, what will happen? If I take minus x common, here alpha is there and here beta is there, we will get alpha plus alpha into beta, which is equals to 0. Now we can write in place of alpha plus beta, what we can write? It is x square minus x into, this is sum of roots. If you observe, our roots are alpha comma beta. Alpha plus beta is nothing but sum of roots. And alpha beta is nothing but product of roots. Which is equals to 0. So this is the way you need to write if two roots are given for a quadratic equation. If you want to write that quadratic equation, you need to follow this one. That is x square minus x into sum of roots plus product of roots, which is equals to 0. Now we'll take one example. That is if 2 comma 3 are roots of a quadratic equation. If 2 comma 3 are roots of a quadratic equation, then how to form a quadratic equation? That means x square minus x into 2 plus 3 and plus 2 into 3, which is equals to 0. Now, which is nothing but x square minus 5x plus 6, which is equals to 0. In this way, you need to write equation in quadratic form if 2 comma 3 are the roots of that quadratic equation. So just once recall this one. Okay, if alpha comma beta are the roots, we can write either in this way or in this way. Okay, now if 2 comma 3 are the roots, 2 plus 3 is 5, so x square minus x into 5 plus 2 into 3 is 6. So which is nothing but x square minus 5x plus 6 equal to 0. This is the required quadratic equation whose roots are 2 comma 3. I hope you got this one. And we'll see some problems based on this one. If alpha comma beta are roots of ax square plus bx plus c equal to 0, then the equation whose roots are 2 alpha comma 2 beta. Just observe here, alpha comma beta are the roots of this equation. So here it is given that ax square plus bx plus c is equals to 0. For this equation, alpha comma beta are roots. We already know that if alpha comma beta are the roots of this equation, what is alpha plus beta sum of roots? Sum of roots is nothing but minus b by a. And the product of roots is nothing but c by a. In previous lecture, we already discussed alpha plus beta is minus b by a. Alpha into beta is c by a from this. And what we need here? We need the equation whose roots are 2 alpha comma 2 beta. Now I am going to write what is sum of these two roots and the product of these two roots. So what we need to find? We need to find equation whose roots are 2 alpha comma 2 beta. That implies x square minus x into sum of roots, which is nothing but 2 alpha plus 2 beta plus product of roots 2 alpha into 2 beta, which is equals to 0. Already we know. If we know two roots, then we can easily form a quadratic equation by taking x square minus x into sum of roots plus product of roots is equals to 0. Now, which is nothing but x square minus x into, here if I take 2 common, 2x into alpha plus beta we will get. What we will get? Alpha plus beta plus 2 2s of 4 into alpha beta we will get, which is equals to 0. Now we already know alpha plus beta, which is nothing but minus b by a, and we already know alpha beta, which is nothing but c by a. Just to substitute in this, x square minus 2x into minus b by a plus 4 into, which is nothing but c by a, which is equals to 0. Now if I take LCM, what I will get if I take LCM? If I take LCM is a here. So which is nothing but a into x square minus into minus, which is plus 2bx plus 4c by a equals to 0 means it will become 0. Equals to 0 means by a equals to 0 means a into 0 again we will get 0. So this is the required equation whose roots are 2 alpha comma 2 beta. Okay, very easy. Ax square plus bx plus c roots are alpha comma beta. From this we can get alpha plus beta and alpha beta. But we need the roots, we need the equation whose roots are 2 alpha 2 beta. So x square minus x into 2 alpha plus 2 beta plus 2 alpha into 2 beta. X square minus x into sum of roots plus product of roots. So from this I have taken 2 common, and 2 into 2 is 4. We know alpha plus beta and also alpha beta. So I have substituted and I got this one. This is the required equation whose roots are 2 alpha comma 2 beta. Now we can solve this problem by using method 2 also. Sir, how to solve method? By using method 2. Here it is given that alpha comma beta are the roots of this equation. So we can substitute alpha in this equation, which is a alpha square plus b alpha plus c, which is equals to 0. Now simply you need to take x is equals to 2 alpha. So why you are taking x equal to 2 alpha? Here we need to find the equation whose roots are 2 alpha 2 beta. Definitely in place of x we need to substitute 2 alpha only. That's why I have taken x equal to alpha. How we substituted x equal to alpha here? Since alpha beta are the roots of this equation. Similarly 2 alpha 2 beta is the root of our equation, required equation, right? So in place of x I need to substitute 2 alpha. It will definitely satisfy. That's why I am taking here x equal to 2 alpha. Now from this alpha is equals to x by 2 we can take. So substitute this alpha is equals to x by 2 in this equation. A into x by 2 whole square plus b into x by 2 plus c, which is equals to 0. Now take LCM. After rewriting this one, x square by 4 plus bx by 2 plus c, which is equals to 0. Now if you take LCM, what you will get? Ax square plus 2 is there here, 4 is our LCM, so 2bx plus 4 is our LCM, therefore 4c, which is equals to 0. This is the required answer. If you observe, this one and this one both are same. This one and this one both are same. Okay, you can solve any of the method, either method 1 or method 2. Okay, once observe this one, we'll solve the next problem. This is the problem number 2. If alpha comma beta are the roots of ax square plus bx plus c equal to 0, then find quadratic equation whose roots are 1 minus alpha by alpha comma 1 minus beta by beta. Now without wasting our time, so I am going to solve by using method 2, because method 2 is very easy to calculate. Then method 1, how you will solve? Simply you need to add these two and you need to product these two. Okay, means multiply these two, and after that you need to substitute in x square minus x into sum of roots plus product of roots. Okay, so that is the method 1, that is the lengthy one. So I am going to solve by using method 2. Okay, right. So now how to solve by using method 2? We already know. Since alpha is the root of this equation, we can write a alpha square plus b alpha plus c, which is equals to 0. After that, what we need to take? We have to find the equation whose roots are these two. So what I am going to do here, so this is nothing but our x only. So in place of x, what I need to take? In place of x, I need to take 1 minus alpha by alpha. From this we need to find alpha and we need to substitute in this equation. So alpha into x is x alpha, which is equals to 1 minus alpha. Now send this minus alpha to this side, which is x alpha plus alpha, which is equals to 1. Now from this we can take alpha common, which is nothing but 1 plus x. If I take alpha common, here 1 is there and here x is there. So from this alpha is equals to what? 1 by 1 plus x. So simply you need to substitute this alpha in this equation. So what you will get? A into alpha is nothing but 1 by 1 plus x whole square plus b into 1 by 1 plus x plus c, which is equals to 0. Now what I will get? If I expand this one, a by 1 plus x whole square plus b by 1 plus x plus c, which is equals to 0. Now if I take LCM, what I will get? LCM is 1 plus x in whole square. Now it is nothing but a only plus b into, here only 1 plus x is there. So we need to multiply with one more 1 plus x, because LCM is 1 plus x whole square, plus c into 1 plus x whole square, which is equals to 0. Now if I send the denominator to this side, it will become 0 only. Now just expand this one, a plus b plus bx, b into 1 is b plus b into x is bx plus a c into, it is a plus b whole square, a square plus 2ab plus b square, a square plus 2ab plus b square, so which is equals to 0. Now again if you multiply inside, a plus bx plus cx square plus 2cx, which is equals to 0. Now simply you need to rearrange this one, cx square plus, in place in these two we have x is there. So if I take x common, b plus 2c plus, and the constant term of a plus b plus c, so which is nothing but a plus b plus c is equals to 0. Now in this way you need to solve. Very simple. You need to substitute alpha in this equation. You will get a alpha square plus b alpha plus c equal to 0. And in place of x we can take this one, because we need to find the equation whose roots are these two. Okay, now I have equated x is equals to 1 minus alpha by alpha. From that I got alpha, and I have substituted again this alpha in this equation. So after that I performed some operations and I got the final answer. You will get one doubt. Sir, why you are taking only x is equals to 1 minus alpha by alpha? Why not 1 minus beta by beta? If I substitute beta in this equation, then I need to take x is equals to 1 minus beta by beta. Okay, I hope you got this one. I hope you got this one. Okay, once observe this one and we'll solve the next problem. Yes, this is the third problem. If alpha comma beta are the roots of ax square plus bx plus c equal to 0, then find the quadratic equation whose roots are alpha by beta comma beta by alpha. Okay, here don't take in the previous how we solve in previous way, the similar way you don't have to take. Alpha is the root of this equation. Yes, you can substitute a alpha square plus b alpha plus c equal to 0. No problem in that. If you take x is equals to alpha by beta, x is equals to alpha by beta, you will not get x into alpha in terms of x and beta in terms of x. You will not get, because if you take x is equals to alpha, x is equals to alpha by 2, alpha by beta, you will not get alpha in terms of only x. You will get beta into x. So you don't have to perform like this. Then how to solve it? Simply first take what are the given here. Alpha by beta comma beta by alpha are the roots. It is given. Now what you need to do? Just multiply and divide with here alpha, which is alpha square by alpha beta, and here also it is beta square by alpha beta. Beta square by alpha beta. Now we already know that alpha beta means product of roots. So product of roots from this equation. What is product of roots from this equation? We already know alpha square by product of roots is c by a. So which is nothing but c by a, comma beta square by c by a. Now if you observe, now you will take x is equals to alpha square by c by a. If you observe, from this you will definitely get alpha in terms of x, not in terms of beta, not in terms of whatever it may be the given. Okay, so you will get alpha is equals to, from this alpha is equals to xc by a, okay, yes, xc by a. So from this what you will get, alpha is equals to root xc by a, okay. Now we already know if alpha is the root of this equation, then we can substitute here. We already know this. If alpha is the root of this equation, alpha is the root of ax square plus bx plus c is equals to 0, then we can substitute a alpha square plus b alpha plus c is equals to 0. Now in place of alpha, just substitute a into root xc by a whole square plus b into root xc by a plus c, which is equals to 0. Now what you will get here? Which is nothing but a into, okay, xc whole square by a square plus b into, okay, what you will get from this? Here root and square will get cancelled. So what you will get? You will not get any square. So b into root x into root c by a plus c, which is equals to 0. Now if I take LCM, no need to take LCM also, here a cancel. So which is nothing but xc plus b alpha square, okay, xc plus b into root c by root a into root x plus c, which is equals to 0. Now this is the required equation. Whose roots are alpha by beta, comma beta by alpha. I hope you got this one. Once observe this one, we'll solve the next problem. This is the fourth question. If alpha is not is equals to beta, but alpha square is equals to 5 alpha minus 3, beta square is equals to 5 beta minus 3, then the equation whose roots are alpha by beta, comma beta by alpha. We need to find the equation whose roots are alpha by beta, comma beta by alpha. Before going to solve this problem, first of all, observe these two. If you observe these two, if I write equation as x square is equals to 5x minus 3, then for this equation alpha comma beta roots, if you want you can check once. For this equation alpha comma beta are the roots. Yes, if I substitute alpha square is equals to 5 alpha minus 3. Yes, if I substitute beta square is equals to 5 beta minus 3. From this we can write x square minus 5x plus 3 is equals to 0. Yes sir. Now we found an equation. We need to find the equation whose roots are these two. If alpha comma beta are the roots of this equation, then what is alpha plus beta from this? It is nothing but 5. Minus b by a means it is 5. And product of roots alpha beta is c by a, 3 by 1, which is nothing but 3. Now we need to find the equation whose roots are these two. That is x square minus x into alpha by beta plus beta by alpha plus alpha by beta into beta by alpha, which is equals to 0. X square minus x into sum of roots plus product of roots is equals to 0. Right? Now x square minus x into, if I take LCM here, alpha square plus beta square by alpha beta plus alpha cancel, beta cancel, which is equals to 0, 1, which is equals to 0. Now x square minus x into, we don't know what is alpha square plus beta square. We know only alpha plus beta and alpha beta. So if I know alpha plus beta and alpha beta, I can easily solve for alpha square plus beta square. How we can solve? Alpha plus beta whole square minus 2 alpha beta. We already know. We already know from the identities. Okay. Now what is alpha plus beta whole square? Which is nothing but 5 square minus 2. What is alpha beta? Which is nothing but 3. Which is 25 minus 6. Which is nothing but 19. Now just to substitute this in place of alpha square plus beta square as 19. So which is 19 by alpha beta is 3 plus 1, which is equals to 0. Now if I take LCM, I will get my answer, right? 3 into x square, 3x square minus 19x plus 3 into 1, which is nothing but 3, equals to 0. This is the required equation whose roots are alpha by beta comma beta by alpha. If alpha square is equals to 5 alpha minus 3, beta square is equals to 5 beta minus 3. This is the previous advanced equation. Okay, so just once observe this one. This is very easy to solve if you know how to form an equation if these two are given, and after that you have to know how to form an equation if these two are the roots of an equation. Very simple. Just once observe this one. We'll see the concept of nature of roots. Nature of roots. Before going to solve nature of roots, we need to know the derivation for the quadratic formula. Okay, if ax square plus bx plus c is equals to 0, now divide both sides with a. What you will get? X square plus b by a into x plus c by a, which is equals to 0. If you want to get the quadratic formula, you need to convert this one into a perfect square. So now I am going to convert this one into a perfect square. Here it is x square is there, x square plus I am going to multiply with 2, which is x only, and here b by 2a I can write. B by 2a I can write. Now 2 gets cancelled. What you will get? X into b by a. So this one I have written like this. 2 gets cancelled and x into b by a plus. So here what I am doing, I am adding b by 2a whole square and I am subtracting b by 2a whole square, and which is plus c by a is equals to 0. So nothing I did. I have added b by 2a whole square and I have subtracted b by 2a whole square. Why we are doing all these things? If you observe from here to here, it is a plus b whole square only. Means x plus b by 2a whole square. X plus b by 2a whole square. Now send these two to that side. What will happen? B square by 4a square. B square by 4a square minus c by a. Now it is x plus b by 2a whole square, which is equals to, if I take LCM is 4a square, means which is b square. Only a is there, so we need to multiply with 4a to the c, which is nothing but 4ac. LCM I did, nothing I did. Okay, only LCM. Now send the square to that side. What will happen? X plus b by 2a, which is equals to root over b square minus 4ac by root 4 is 2, root a square is a, but we will get here plus or minus. Root means here, square means if I send square to that side, either it is positive or it may be negative. That's why I have taken here plus or minus. Now send this plus b by 2a to that side. What will happen? X is equals to minus b by 2a plus or minus root over b square minus 4ac by 2a. Now in both we are having 2a, so take LCM 2a, you will get minus b plus or minus root over b square minus 4ac by 2a you will get. So this is the quadratic formula method. This is the quadratic formula. Okay. Now very simple. I have converted into perfect square, and after that I have taken the square to that side, and after that I sent b by 2a to that side. I will get this one. Now from this we are going to see nature of roots. This is very important, especially in root we have b square minus 4ac. So that b square minus 4ac we can write as discriminant, that is root delta by 2a. Here discriminant, which is nothing but b square minus 4ac, this one we call as discriminant. Okay, now this discriminant is very important here. If discriminant is equals to 0, what will happen? If discriminant is equals to 0, this total term will become 0. This total term will become 0. If this total term will become 0, what you will get? You will get only minus b by 2a. Only minus b by 2a. But for a quadratic equation, we already learned that in our first lecture. Okay, for quadratic equation, we have two roots. But if I get here discriminant is equals to 0, then I am getting only minus b by 2a. Minus b by 2a, only one root I am getting. That means here the roots are equal. We will get minus b by 2a only, but we will get another minus b by 2a also. Means two roots we will get, both are equal we will get. That is minus b by 2a. Both are real and equal we will get. If discriminant is equals to 0, what we will get? Roots are real and equal. What we will get? Roots are real and equal. Now if discriminant is greater 0, what will happen? Let us see. If discriminant is greater 0, greater 0 means, let us take 4. Whatever it may be, you can take. So I am taking 4 because root 4 is, I know, 2, right? So here if I take discriminant is 4, if I take discriminant is 4, which is root 4 is nothing but 2, means 1 I will get minus b plus 2 by 2a, and one more I will get minus b minus 2 by 2a. Two roots we are getting, both are getting real only, and both are unequal. Two are unequal, you can check. Minus b plus 2 is 1, minus b minus 2 by 2a is 1. So both are unequal and real. So here we are getting real and distinct. Real and distinct. Okay, real and distinct, or real and unequal. Now the third one, that is discriminant is less than 0. If discriminant is less than 0, then what I will get? If discriminant is less than 0, let us take it is minus 4. Discriminant is minus 4. So if discriminant is minus 4, then root minus 4. Root minus 4, what I will get? Root minus 4 is root I square into 4. Because I square value is minus 1. Minus 1 is I square. Okay, I square into 4, which is nothing but I square is I only. Root 4 is 2, which is nothing but 2i I will get. 2i. One is minus b plus 2i by 2a. Another one is minus b minus 2i by 2a. Means we already know that it is a complex number, right? And conjugate also, because one we are getting positive in the middle and one we are getting negative in the middle. That means we will get complex conjugate roots we will get. Complex conjugate we will get. Complex conjugate roots. Complex means what? In a number which is in the form of a plus ib. A plus ib. Conjugate means a, if for a plus ib, a minus ib is conjugate. For a minus ib, a plus ib is conjugate. Therefore these two are minus b. What I will get here? Minus b plus or minus 2i by 2a. Minus b plus 2i by 2a, minus b minus 2i by 2a, we can call as complex conjugate roots. So this is the nature of roots. We'll see one more time. So I got here x is equals to minus b plus or minus root delta by 2a. This delta is very important. This delta we can call as discriminant. If this delta is equals to 0, we will get x is equals to minus b by 2a. But we need to get two roots. That's why here the roots are equal. And the real also, we are not getting any imaginary term. Therefore, we can say that if discriminant is equals to 0, roots are real and equal. If discriminant is greater 0, whatever it may be the value you can take. I have taken 4, or you can take 9 or 16, whatever it may be. Whatever it may be, 2, 3, 4, whatever it may be, you can take. So here, for understanding purpose, I have taken root. I have taken 4. Okay. Now what I am getting? I am getting real roots only, but distinct I am getting. And for the third case, if discriminant is less than 0, I have taken minus 4. So I got here imaginary term. In after plus or minus, I am getting in imaginary term. Therefore, we can say that it is a complex conjugate number. Therefore, we can say that if discriminant equal to 0, roots are real and equal. If discriminant is greater 0, roots are real and distinct. If discriminant is less than 0, roots are complex conjugate. So, who deciding the nature of roots? The discriminant is deciding. Okay, this is the deciding factor for the nature of roots. I hope you got this one. Okay, now we'll see some problems based on this nature of roots. This is the first problem. Find the nature of roots of the following quadratic equations. X square minus 5x plus 6 equal to 0, x square minus 4x plus 4 equal to 0, x square plus 5x plus 7 equals to 0. Right. Now, we need to find the nature of roots. Here we don't want to find the roots. He is asking what is the nature of roots. Nature of roots, how we will find out the nature of roots means by using the discriminant. What is the discriminant formula? Here we have discriminant is b square minus 4ac. b square minus 4ac. Now here what is a value? A value is 1. For first question I am writing a value is 1. And what is b value? We need to compare with ax square plus bx plus c. Here it is minus 5. And what is c value? C value is 6. Now just you need to substitute in this discriminant, that is b square means minus 5 whole square minus 4 ac. Now what is 5 square, which is 25 minus 24, which is 1. 1 means which is greater 0. Greater 0 means definitely we know roots are real and distinct. Real and distinct. Okay. Now what is the second problem? What is second problem we have? A value is 1. Ax square means a value is 1. B value is minus 4. And c value is 4. Now just substitute in discriminant. What you will get? Discriminant is equals to b square minus 4 whole square minus 4 a, c value is 4. Now what is minus 4 whole square? 16, and 4 4s are 16. So discriminant we are getting 0, means discriminant equal to 0 means roots are real and equal. Real and we will get equal roots for this equation. For this equation we will get equal roots. Equal roots we will get. For this equation we will get distinct roots. Okay, now we'll see the third one, that is this one. What is a value here? A value is 1 and b value is 5 and c value is 7. Again discriminant, b square minus 4ac. 5 square minus 4ac, which is nothing but 25 minus 28, which is minus 3. We already know minus 3 is less than 0, right? Minus 3 is less than 0. Less than 0 means roots are complex conjugate. Complex conjugate roots we will get. Complex conjugate. Right? I hope you got this one. Okay. If we get discriminant greater 0, real and distinct. If we get discriminant equal to 0, real and equal. If we get discriminant less than 0, complex conjugate. Okay. Once observe this one, we'll solve the next problem. If a comma b comma c are non-zero real numbers, then comment on the nature of roots of the equation x square minus 2ax plus a square minus b square minus c square equal to 0. We need to say what are the nature of roots of this equation. Okay, here there is no numbers directly. Here we need to consider these things only, a b c, like that only. Okay, right. Now if I want to decide the nature of roots of an equation, we need to find the discriminant. First of all, what is a value here? A value is 1. Discriminant is equals to b square minus 4ac. So why you are taking here capital letters? Means already in the question small letters are existed, that's why. Okay, so discriminant is equals to b square. B square means minus 2a whole square minus 4. Okay, a value is 1 and c value is a square minus b square minus c square. Okay, now what I will get here, which is 4a square minus 4 into a square, which is again 4a square, minus into minus plus 4b square, and minus into minus plus, which is 4c square. Here 4a square 4a square cancel. Now what we will have here, 4 of b square plus c square. Now just observe this one, 4 of b square plus c square. B is whatever, here it is saying that non-zero real number. Real number means whatever it may be the number, minus, plus, or whatever it may be. So whatever it may be the number you can take here. Positive, if you take positive, everything will be positive. B square is positive, c square is positive, 4 into positive is again positive, greater 0 we will get. If you take b is negative and c is negative, you will get again positive only. B square means if you take minus 2 whole square is plus 4 only, and if you take minus 5 whole square is plus 25 only. Okay, always you will get this one is greater 0. If it is greater 0, then what are the nature of roots? Nature of roots are real and unequal, otherwise real and distinct, whatever it may be. So this is the nature of roots of this equation. Okay, once observe this. Third problem, if sine square alpha into cos square alpha is equals to sine square beta, then the nature of the roots of the equation x square plus 2x cot beta plus 1 is equals to 0. Again, if I want to find the nature of roots, I need to find discriminant. Discriminant is equals to b square minus 4ac, which is 2 cot beta whole square minus 4 into a into c. A value is 1, x square coefficient is 1, and the constant also 1. What we will get here, 4 cot square beta minus 4. Now in this I am taking 4 common. If I take 4 common, which is cot square beta minus 1. Now we already know that cosecant square theta minus cot square theta is equals to 1. Okay, cosecant square theta minus cot square theta is equals to 1. Here it is cot square theta minus 1. So in place of cot square theta, what we can write, cosecant square theta minus 1. Cosecant square theta minus 1 is equals to cot square theta. So in place of cot square theta, I am substituting cosecant square theta minus 1. So which is 4 into, in place of cot square beta, I am writing cosecant square beta minus 1, and here one more minus 1 is there, it is minus 1. Now 4 into, which is cosecant square beta minus 2. Now in place of cosecant square beta, I am substituting 1 by sine square beta. We can write 1 by sine square beta minus 2. Right? Now in place of sine square beta, I am substituting 1 by, here in place of sine square beta, we can substitute sine square alpha into cos square alpha, which is minus 2. Now take LCM, what you will get? If you take LCM, what you will get? Which is equals to 4 into 1 minus 2 sine square alpha cos square alpha by sine square alpha into cos square alpha. Sine square alpha into cos square alpha. Now here I am multiplying and dividing with 2, and here also I am multiplying and dividing with 2. Otherwise, if I multiply both numerator and denominator with 2, what you will get? 2 minus 4 sine square alpha into cos square alpha by 2 sine square alpha. Here also I need to get 2 sine square alpha cos square alpha. Now here I need to get 4, but here only 2 is there, so I am multiplying here 2 and here 2. Okay, so what I will get here, 8 into 2 minus, which is nothing but sine square 2 alpha only. It is also sine square 2 alpha. Why it is sine square 2 alpha? We know that sine 2 alpha is equals to 2 sine alpha cos alpha. 2 sine alpha cos alpha. Sine square 2 alpha is nothing but 4 sine square alpha cos square alpha, if I do squaring on both sides. Now just observe this one. Sine square 2 alpha. Sine square 2 alpha. What is the sine range here? Sine range is minus 1 to 1. So whatever it may be the number, you can take from -1 to 1. Sign range is here -1 to 1. Whatever it may be the number, you can take in between these two, -1 and 1, and substitute here. You will get positive only. You will get positive only. And what is the highest value here? Highest value is 2. Okay, maximum value is 1 here. So if you substitute here maximum value 1, so 1 square is how much? Again 1 only. So 2 minus 1 is 1 by 1 square is 1. 2 minus 1 is 1. 1 by 1. You will get again 1. So 8 into 1, 8. So this is obviously greater 0. This is obviously greater 0. If it is greater 0, then roots are real and unequal. Real and unequal. Very simple. Very simple. Here sin square to alpha maximum value is 1 only. And sin square to alpha maximum value here also 1 only. 2 minus 1 is 1. 1 by 1 is 1. 8 into 1 is 8. So which is greater 0. So that is what I am trying to say. Okay, just once observe this one. Okay, you will get everything. We need to use this condition. If we want to solve this one, we need to use this condition. Okay, at the end we will get greater 0, that is real and unequal is our answer. So sin 2 alpha, this is the formula we will get in trigonometry. Sin 2 alpha, sin 2 theta is 2 sin theta cos theta. Okay, once observe this one, we'll solve the next one. Let p comma q belongs to 1, 2, 3, 4, then the number of equations of the form px square plus qx plus 1 equal to 0 having real roots. He is saying that what are the values from this we can take from this and fix it in this equation so that that equation may have real roots. In place of p comma q, we need to substitute the values which are given. P comma q belongs to 1, 2, 3, 4. Only 1, 2, 3, 4 we need to take. We need to substitute 1, 2, 3, 4. Either 1 here, 2 here, 3 here or 4 here. Or also we can take 1, 2, 3, 4 here. And we can fix it so that that equation have real roots. Okay, that is the question. So real roots means for this equation when we will get real roots? If it is the equation px square plus qx plus 1 equal to 0. When we will get real roots? Real roots we will get discriminant greater or equal to 0. Why greater or equal to 0? For greater 0, roots are real and unequal. For equal to 0, roots are real and equal. Real, he is saying that only real. He is not saying real and equal, real and unequal, he is not saying. Only real. Real means either it is real and equal or it is real and unequal. So that's why I have taken here discriminant greater or equal to 0. What is discriminant? B square minus 4ac, which is q square minus 4p into 1, which is greater or equal to 0, which is q square minus 4p greater or equal to 0. Now q square is greater or is equals to 4p. Now once observe here, I am taking p values. If p is equals to 1, what will happen? If p is equals to 1, what will happen? Q square is greater or is equals to 4. Now substitute for q. If you substitute 1 square is not greater or is equals to 4. Next, 2 square means which is yes greater or is equals to 4, it is correct only. Next, 3 square is 9, yes, which is also correct only. Next, 4 square is greater or is equals to 4, yes, it is also correct. For p is equals to 1, what we are getting? For p is equals to 1 and q is equals to 2, we are getting, this is one pair, p comma q, and 1 comma 3 it is also satisfying, and 1 comma 4 also it is satisfying. So here we are getting 3. Now let us check for if p is equals to 2, what will happen? If p is equals to 2, q square is greater or is equals to 8. Now let us see. Q is equals to 1, I am substituting. 1 square greater or is equals to 8, it is not possible. And 2 square which is greater or is equals to 8, it is also not possible because 4 is not greater 8, 4 is not equal to 8. And 3 square I am taking. Yes, 3 square is greater or is equals to 8, only 3 square value is 9. Yes, we will get. And 4 square is greater or is equals to 8, it is also correct only. Here we are getting 2, that is 2 comma 3 and 2 comma 4. 2 we are getting in this. Okay, next. If p is equals to 3. What will happen? If p is equals to 3, what we will get? Q square is greater or is equals to 3 means 12. 12 means what we will get here? Only 4 square we will get. Only 4 square. 4 square is greater or is equals to 12. This is correct. 1 square, 1, 2 square, 4, 3 square, 9. We will not, it is not, 9 is also not greater or equal to 12. Therefore, only 1 we will get, that is 3 comma 4. Only 1 we will get. And if p is equals to 4, what will happen? If p is equals to 4, here I am calling. If p is equals to 4, q square is greater or is equals to 16. What we will get? Only 1 we will get, that is 4 square is greater or is equals to 4 square is greater or is equal to 16. We will not get anything. Okay, so that's why here 4 comma 4. So how many we are getting? Here 3, here 1, 2, 3, and here 4, 5, and here 6, and here 7. So our answer is 7. It is very simple. He is saying that real roots means greater or equal to 0. After that I have taken for p, and after that I have solved for q. Okay, so it is very simple. Okay, once observe this one. And in this lecture we completed 2 topics. Those are how to form a quadratic equation and also the nature of roots, and we solved some problems based on these 2 concepts. And thank you for watching.